Hey friends, I'm Shaptarshi. I just completed my master's in chemistry from IIT Kanpur. And in this video series for IIT-JAM exam, I wanted to cover all the different types of numerical problems that come for physical chemistry. And by doing those problems, I'll be explaining the concepts as well. In physical chemistry IIT-JAM, 90% of your questions will be numerical based. So it's very important. And just like this video, I'll be making similar videos on different physical chemistry topics as well. So with that, let's get started with this one.
Hello friends, so in this video we'll look at the concept of entropy from the second law of thermodynamics, which is a very important part for your IIT-JAM. Some concepts I'll be talking about, and the numericals also we will solve in this problem. So the entropy, as you know, for the universe, it's the entropy of the system plus the entropy change of the surroundings. Okay, and some things that you should know, because this comes in MCQs and other concepts are asked, is that for a reversible process, the change in entropy of the universe system surroundings is zero, right? For an irreversible process, the entropy of the universe is increasing because as the entropy of the surroundings is increasing, and this is also called the second law of thermodynamics, is that the entropy of the universe is increasing. So remember the difference between reversible and irreversible process. So which is more, the entropy for the gas, liquid, or solid? As we know that entropy in the physical significance responds to chaos or disorder. So for gas there is more the entropy value for the, like, if you consider the same substance, so the entropy value for the gas will be more than it is for the liquid state of that substance, and the liquids will be more than it is for the solid state of that substance. At the equilibrium position, the change in entropy is zero. The change in entropy, you remember this, okay? It's not the entropy, this change in entropy that we're talking about. So the change in entropy can also be said as the heat divided by the time, and this phenomenon is used when we're seeing your phase changes. This is very important. During the phase changes, we can relate our del H with our del S, and del H is the your enthalpy. So suppose a fusion is happening, so the T over here is the melting point temperature. For a vaporization process, the T over here is the boiling point temperature. Similarly for sublimation and other processes, right? So this is the concept. We will see a numerical from this part in the upcoming part, right? For an ideal gas, so the change in entropy for that is your given by this formula: NCV ln T2 by T1 plus R ln V2 by V1, right? So I'm not like deriving any formula over here, because derivation is not normally asked in the IIT-JAM, and revising for this last moment derivations, you might mess it up more than because there's a lot of things to revise apart from physical, inorganic, organic. So I think you guys should know the basic concepts and the formulas. Okay, don't just mug the formulas, know what it is means, solve some problems, guys. That is the main thing. That's why I'm solving the problems. That is how I prepared in the exam time also. If you don't solve the problems, I don't think you will do well. Okay, not mean to discourage you, but that's the truth. So mixture of gases, so the change in entropy for the mixture of gases is given by minus nr, where xi, this is a summation, right? We'll see a problem from this just right now only. This is the xi is the mole fraction of the species I. Whichever species is given, that is the mole fraction. Remember, it's a mole fraction. And nr, you know, n is the moles and r is your what is this, the gas constant, right? So, and very important, remember this minus sign, because sometimes what they will give in this, you know, MCQs or something, they will give minus 22, they will also give plus 22. Very smart people there. So remember this minus sign that is in the formula. Okay, so now let us look into the numericals with this concept, right? I think this is a good way of going. I'm telling you the concept and I'm solving the numerical problems also. By doing this, you get the basic idea and just analyze the problems that I'm doing, right? Try to understand them. And if you know the types of problems, nothing should stop you of doing a similar kind of problems in the exam, right? You won't get any matching questions, I can tell you that. Find melting point of KCl given. So del H is given, del S is given. So as I said in just previously, that del S is also given by del H your by T, and for your melting, so something is melting. So if you see, this is fusion. Melting means your what is solid to liquid. So this will be your melting temperature. Nothing then. It is so easy, right? Let me use a black pen for more emphasis. Is that what is del S? Then del S is given your 0 0.0. So remember the units that's given, right? Because both are in kilojoules, we don't need to convert anything actually. It is 0.007 equals to del H is 7.25 and Tm. So if you do this, the answer that is given over here is 1035.7 Kelvin. Tm it is given as 1035.7 Kelvin. So just check it up. This should come if you do the Tm, right? And okay, so that was the concept. Similarly, they can similarly give you a vaporization process. They will give you the vaporization process. They will tell you to find the TB, the boiling temperature. Nothing. You, some people will think, oh, TB, now how will I find TB from the del S? I don't know the formula only. No, you know the formula, you don't know the concept. That's why I gave you the concept. So del S simply will be vaporization, del H vaporization, and this will be TB, right? So similar problems they can also give, right? For 1 marks this can come. So let us look at one more problem. This is a very standard problem that was actually asked in IIT-JAM only, I believe. Uh, I like this problem a lot. It kind of clarifies a lot of things. I'll just show you how it's done. So again, it's a very, you're seeing it's such a, so much is written. So people, when they see the problem, such long words, sentences, they will get scared. So as I said, go step by step, read line by line, write the given information, write the relevant formula, and you solve. Even in fact, I can give write the algorithm also of solving problems. So first, let's see, isothermal reversible compression. So remember, it's an isothermal process. That means delta is 0, right? For 1 mole of gas where pressure is increased from 5 atmosphere to 30 atmosphere at 300 Kelvin, entropy change. So what did we learn in the last video is that del S can also be written as NCV ln T2 by T1 plus nR ln V2 by V1, right? So I believe this was the formula, right? And over here, so okay, so one mistake I made is that, so this is a formula also, but over here you also need to know the pressure form. That's why it's very important to know all the forms. I'm again writing in black to make it more emphasis actually. So this will be nothing but NCV ln T2 by T1. I'm writing what in pressure form, nR ln P1 by P2, right? So this is the form, right? So over here, okay, so one mistake I made, this is actually CP over here, this will be CP. I believe in the formula also I wrote that it was CP only, right? So see over here they have not given the CP value. Okay, some people will think, okay, they have not given the CP value, then how will I do this problem? See, it is given that is an isothermal process, right? Isothermal means change in temperature is, there's no change in temperature. So T2 and T1, that is basically the same, and if that is the same, the ln of that will actually get nullified and this will come as 0, this whole part. So you don't need CP for that, and this will be nR ln P1 by T2. What is n? What is R over here? Let us take it as 8.314 ln P1 by P2. What is P1 that is given over here? The initial pressure was 5 atmosphere, right? And the final was 30, if I'm not wrong. Let me just check one more time. 5 atmosphere to 30 atmosphere at your 300 Kelvin. So we don't need the temperature as it is, right? So see, this is a trick they give. Sometimes this is a very common trick given in the exams, is that they give extra info to confuse students. Extra info to confuse the students. Right. That if you have the concept, I'm telling you again and again, no one can stop you from getting the answer. And you're seeing, it's not a big deal of doing these problems. You need to do it methodically, as I'm telling you, and avoid silly mistakes. So if you guys do this thing, the answer that should come around is your 14.8. So ln 5 by 30, again in the last video also I showed you how to use virtual calculator. Again I'll do this for you also. So ln 5 by 30 into 8.314. Let us see how it is done in the virtual calculator. Okay, So in virtual calculator, I again first have to press the 0.16. Now I have to make the ln of this. So let me take the ln of this minus 1.79. That is coming as, and this will be into 8.314 into 8.314. Answer is coming as minus 14.89. So this will be our answer. Okay, so our answer will be minus 14.89. Yeah, so I forgot to get the minus sign over here actually. So the answer will be, so we are getting the right answer. Okay, so the answer is minus 14.89, and it's always good to write the like as I'm saying, always to write two significant figures after the decimal point. After decimal, please make sure you do this. Okay, you don't want to miss out marks just because of a very silly mistake like this. So you understood this problem. If you don't understand, please look at it up again, how I'm doing it. If you have some problem, do comment in the comment section. I will reply to it. Okay, I was a bit busy in quite a few days, but now I'm a bit free. So last problem, let us see how it's done. So this is at NTP. So NTP means normal temperature pressure. 2.8 liter of oxygen is mixed with 90.6 liters of hydrogen. Entropy change. So what did I say in the last, like just like previously only, that del S mix equals to NR summation of Xi ln Xi, where your Xi is what? It is a mole fraction. What is N over here? So is N, if not, let me just check. Okay, so over here, xi, as I said, is a mole fraction, but there is a different way you have to tackle this problem actually, is that we need to find the mole fraction. So we need to find, this is a bit advanced, but I'm just telling you, maybe the problem in exams will be a bit easier than this, but I'm telling you how to approach, right? If this comes in NAT, you should not skip all these questions because NAT have no negative marks, so you always approach, and you can do this actually. Just see how I'm doing. So xi is a mole fraction. So mole fraction is what? It is the amount of a substance, it is the amount of oxygen in this mixture of hydrogen and oxygen, or it is the amount of hydrogen in your hydrogen oxygen. So the amount of oxygen in this hydrogen and oxygen mixture is 2.8 liters plus 2.8 plus 19.6, right? And what is the amount of like the mole fraction, right? The mole fraction, if we are find out for our what do you say, hydrogen, that we find out, if that will be 19.6 divided by 2.8 plus your, sorry, this is 19.6. Again, I'm making this mistake, right? I'm seeing the 19.6, but I'm writing 9.6. Please don't make these mistakes. It happens very commonly, I know, but be alert. It's very well. That's why I told you guys in this video of I think Realistic GAN, that channel, I told you guys that you should give mock tests or any practice sessions you do, whatever practice sessions you do in that time range of exam. You have exam from 2:30 to 5:30, right? Give your mock test during that time, so that in the exam time also, in that time range, you will be active, you won't feel sleepy, and your brain will be active over that time, right? So over here what we have is that so if we find the mole fraction, we can, so ln we can find. So let us do this problem. So tell S, I'm also not totally sure whether I'll get the answer because after a long time I'm doing this, but so let me, you have to again find out these values, so that is a bit tough. So let me just quickly do this. Okay, 2.8 plus 19.6. If you're looking at this video, you can also try doing it in your own calculator. Quickly, let me just check how much it is. 2.8 plus. Okay, so sorry, this one, huh? That was a sign before it actually. 19.6, 22.4. Okay, great then. And okay, 22.4. So if I do now this divided by your 2.8 and you have to take the inverse of it. Okay, great. So 2.8 by 22.4, that is one part of your 8 parts, right? So 2.8 into 8 will be 22.4, right? So what I did over here, I'll just show you, is so this term is actually, if I'm breaking the terms, this is 2.8 into 22.4, this will be 19.6 divided by 22.4, right? And let me just rub this portion out. I'll just show you how it's done. And so I found out that 2.8 into 8 will be 22.4, right? So 2.8 by 22.4 will still be 1 by 8, and if because it's a mole fraction, the other should be 7 by 8, right? And we can actually check it out. We can actually check it out with a calculator, because why it will be 7 by 8, because like it's so like 1 minus 1 by 8 will be your 7 by 8. And why this is, I'm doing 1 minus this, because mole fractions will add up to 1. That's the reason. So what I'm trying to say over here is that for cross checking it, we will 19.6, so 19.6 into 8 divided by 7 equals to 22.4. So see, because I know I have done this, now I'm more confident that I'm going in the right way. So cross checking sometimes you can do, sometimes if you don't want to do, it's fine. So we found the mole fraction. What we need to do is simply place it in this formula. Okay, so over here, as you can see, that xi value is, so let me take, they have given the answer in calories. Okay, the answer is given in calories, so I'll take r as your 1.987, right? That's the value for r if we're taking in calories. So 1.987, this will be so let us do for oxygen. This will be 1 by 8 ln 1 by 8. For your hydrogen, it will be 7 by 8 ln 7 by 8. So okay, so over here I didn't put the n. When n is not given, or because see, the total, we are taking the mole fraction, right? So we can take n as 1. If n was given, like n is 2, n is 3, then you have to take the value. But if it's not given, specified, you can always take n as 1, right? So okay, so we have done this, you guys know this. So you have to do this calculation, which is a bit tasking. And don't forget the minus sign over here. Okay, oh, I'm feeling a bit sleepy today. I'm making some very stupid mistakes, but that's why I'm saying, guys, you take the mock tests during the time of the exam, so that you don't make the silly mistakes. It's not 19.87, it's 1.987, right? Okay. Okay, so let me just quickly do this. So answer that is given over here, what is the answer that is given? Answer that is given is 0.754 calories uh, per degree. So they have given by per degree, when right by Kelvin also. It's like the energy by the temperature. So let me just check this calculation. So 1 by 8, we have to take the ln of this. This we get, and this will be into 1 divided by 8, right? So on one portion we have minus 0.25. So one portion we have 1.987. This is how much? Minus 0.25. And the other portion, that, okay, 2 is 259. So let me just write 26. I should write, okay, so let me just write 26. And the other portion that I want, so I did 1 by 8, so now I'll do 7 by 8. So you guys see, so I'm doing the problem, you guys are seeing, it is so important to be alert in the exam, right? I'm telling you again and again, try not to make the silly mistakes. If you don't make the silly mistakes, your chances of going to IIT will skyrocket, right? Truly, no doubt. Minus 0.116, okay, or I can write minus 0.12 if I'm converting to the two figures after decimal. So this will be minus 0.12 And if I do the calculation, 1.987, this will be minus 0.38. Let me again do this calculation. 0.38 star 1.987. If I'm not wrong, it is 1.987, right? 0.755, right? So what is the answer that is given over here? Answer is 0.754, right? Yes. So we got the answer. Even I'm feeling good because I also did the problem. There's always a very good feeling that comes when you get the right answer. So see, if the answer is 0.754, I'm guaranteeing you they will give a range something like 0.52 to 0.57 or something like that. Whatever they give, right? They will give a good range. Normally they give this range of they plus minus 0.03 or whatever the range is. They will give a good range. Okay. So even if you don't get 0.54, it's fine, right? You're getting 0.75, the first two digits, right? You'll obviously get the right answer, right? But obviously they gave a range of what is the correct answer. They won't ask that specifically exactly you have to point out this answer. So guys, you saw how we are doing the problem, and very important, the last problem, as I said, don't forget the minus sign that I put over here. So I know it's a very long video, but this video was, I believe, truly helpful. I showed you every process, right? Like in between, if you make mistakes, how to correct it or something, and something like that. Okay guys, in the next part we'll look at some things like the Maxwell's part, some of the thermodynamics part, and although the Clausius-Clapeyron equation, which is very important. With that, just analyze the problems. I told you all the different types of problems. Now it's your part to analyze it, understand it, and maybe solve some other problems if you have time. Otherwise, it's fine. Okay.